Hi, today is June 11th, 2024. Again, today we're going to continue talking about the Gao Kao math exam. Okay, so given a set A, where x is between x cubed between -5 and +5. And then another set B is discrete number. It's -3, -1, 0, 2, and 3. Now they ask for the intersection between set A and set B. Okay, so how do we do that? So first, let's look at the set A. So for set A, we know the element of the set A follows that. Right? So x cubed basically means x times x times x 3 times. In order to get the cube, we have to do something like that. X 5 1 3. Why? Because x cubed, if we take 1/3 of it, and then that will be x 3 times 1/3 will be x1, which is x. So that's what we have right here. Now, if we have a calculator, this problem is relatively easier. However, I'm assuming for this test, nobody allowed to use the calculator, because otherwise it was so easy with today's calculator. You can do a lot of cheating over there, right? So I believe that it was forbidden to use calculator in the test. So if that is the case, let's look at it. First, look at right here. So since this is a negative number, we know if we have a number called -1, right? If x equal to -1, then x cubed can be rewritten as x times x times x. In this case, will be -1 times -1 times -1, which is again -1, right? So when x equal to -2, then we will have x cubed equal to x times x times x, which is -2 times -2 times -2. So that will give us -8, right? But since what we have is -5 right here, that means the solution of this part right here is going to be a number between -1 and -2, right? Because otherwise, your number is going to be, after we take a cube, the number is going to be in between those two numbers, right? Because we try to solve for x, right? And then we do not have a calculator, so we want to find out exactly what the number is, but we don't, right? But the thing we know is the following. We know the number is between -1 and, right here, -1 and the -2. Why? Because if the number is -2, after take the power of 3, that will be -8. Okay, then if the number is -1 and then we take the cube of it, that's still -1. So in other words, if we have a number 9, if this is a 0, right? And then let's say this is -1, and then this is a -2. We know this number right here got to be somewhere in between, right? And then that number times themselves 3 times is going to be -5. Why? Because if this is a number, -2 times 3 times, it's going to become a -8. and then if it's -1, then it becomes -1. So we know -5 is in between -1 and the -2. I'm sorry, -1 and the -8. So that's that. Okay. Similarly, we can do in this part, right? So this part, if we say x equal to +1, then x cubed will be 1 times 1 times 1. That would be 1, right? And then if x equal to +2, then x cubed will be x times x times x. That will be 2 times 2 times 2 equal to 8. Okay, so since this number right here is 5, then that 5 is between 1 and 8. So we know that number, if this is 1 and then 2, and then we know that number is somewhere around here. I mean the x, all right, for this number. So this pretty much is our set A. Okay, so now let's look at the set B. Set B is just a discrete numbers. It is this number. Let's say this is a -3, and then -1, and then 0, and then +2, and then +3. So these dots, the red dots are the set B. Okay, now we have to look at how many red dots in between. Why? Because A intersect B, that means it need to satisfy both the set A and set B. So those 2 points are the only 2 points that satisfy that. So indeed, A intersect B is going to be a set contains 2 elements. So that's it. So that's the result for first problem. Okay, let's doing another problem. This is a brand new problem. Okay, we say given z over z subtract 1 equal to 1 plus I, they want to looking for z. Okay, so how do we do that? So first we times z subtract 1 on both sides. 1 plus I, z subtract 1. So those are the common term. We multiply on both sides. So one thing about the equal sign is following. If we use the same operation, in this case is the multiplication with the same number, which is z subtract 1 on both sides, then the equal sign still holds. So this cancel out. So on the right hand side it's just a z. On the left hand side we use distributive law, which means we pick up the first element times each element right here, which is 1 times z plus 1 times -1. And then we use the second element times each of the element right here. That would be I times z subtract I, right? So I times -1 is just a -I. Then we simplify this a little bit, so it would be z, that would be subtract 1 plus iz subtract I. And then we combine the same we put everything contains z to another side, so it will be z subtract iz equal to -1 subtract I. Now let me see, we doing the following. So that's what we had before. Then we combine the like term, so z subtract z, that's gone. So we have I, negative I times z equal to negative 1 subtract I. Then we can times negative 1 on both sides, right? So negative 1 subtract I times negative 1. Again, we use the same operation, which is the multiplication, applied to the same number, which is negative 1. So the equal sign still holds. Negative I, negative 1, that would be IZ equal to basically negative 1 times negative 1 is positive 1 plus I, right? And then we divide by z on both sides, we will have 1 plus I divided by I, and then that we times another I on both the numerator and the denominator, right? Again, for the fundamental complex number, I squared equal to negative 1. That's the definition, you have to memorize that. So for the denominator, we got a negative 1 because I times I is I squared. Here, distributive law, again, we got I times 1, which is I, plus I times I. Again, I squared equal to negative 1. We got I subtract 1, subtract 1. Again, we can times I subtract 1. We can times negative 1 on both the numerator and the denominator. We can get rid of the denominator because negative 1 times negative 1 is positive 1. Anything divided by positive 1 is the thing itself. So top distributive law will be I times negative 1 plus negative 1, negative 1, and then that will be 1 subtract I. And then that's pretty much it. Okay, so we'll discuss more next time. Thank you. Bye-bye.